Hello, everyone. This week, you learned about inferential statistics, specifically mean difference test. In most statistical classes, the first inferential stat that students usually learn and run are mean difference tests. It's quite simple to understand and easy to run. In our case, we're going to conduct t-tests and ANOVAs in our studio, and we're going to run the most kind of basic t-tests and ANOVAs. So what's the difference between t-test and ANOVA is that t-test usually is ran when there's only two different points of means. It could be two different groups or two different measures at different time. So if we measured like height and weight at one time, and height and weight after, let's say, a basketball camp or something like that, then we can compare the mean difference for the same person at time one and time two, right? That could be a pair t-test. And if we ran baseball camps in Texas compared to, let's say, Florida, then we have different groups, right? Then we can run an independent t-test between groups. But when there's more than two means, more than two groups, then ANOVA is ran to detect the statistical significance of mean differences among those multiple means. And you learned about that in the lecture, and ANOVA usually requires a post hoc test to identify which means are different from another. So we will run those. We'll run some of the most basic forms of t-tests and ANOVAs in this class today. All right, so let's begin. You might have noticed that we are using a different data set for this week. This is because um, when looking at the demographical data, there were some missing data there. So after deleting those missing data, now we have generated a new data set with new data cleaning data set. So let's download this and make sure you copy and paste that file downloaded. So I have this download on my downloads folder. I'm going to copy and paste it to my documents folder, which is the default folder that RStudio uses, right? So I just copied and pasted it there. So after I click this home button, you can see that the Excel file is now showing on the RStudio window. So I'm going to click this and import the data set. The data set looks correct. And you probably know that now this is the code asking to load the read Excel package. And this is the command to load our data set, right? So I will click import. You will see that the command is ran correctly. And comparing to our previous data set, you can see that 13 observations, 13 respondents were deleted because they had some missing data. They did not respond to some of the demographical questions. So we have our data set loaded in RStudio. And, our pattern is loading the right R packages. And you're going to run the functions that I provide to you and analyze and interpret the results. So if we look at the data set, we have two types of genders recorded in our data, which is suitable for a t-test. On the other hand, our degrees ordered ranges from 1 to 6. 1 was freshman, 6 was PhD students. So in that case, we have to run an ANOVA because we have more than two means. And our dependent variables are the 8 ones that we've been using so far. So let's click the script and let's copy and paste the necessary commands. So we already did this part, right? I already loaded the data set on RStudio. And next, what we're going to do is we're going to perform independent t-tests. And this is the t-test command that is in our language. So if you type t-test and open the parentheses, then you can designate the file name. And it's asking you which file you're going to use. And then you can designate the variable of interest, right? So this is what we're doing. This is what I provided to you here. And the group, so this is the variable that we're going to compare the means. We're going to compare the means of extroversion across two groups, which is gender. The group variable that we are using is gender. And we're assuming that the variances are equal across groups. There is a robust students t-test that we can run, which can be ran even though the variances are unequal. But we're going to keep it simple in terms of statistical analysis of mean differences in our class because it's kind of experiencing it. So you can just use the default of considering the equal variance to be true. And these are all the commands for all the other variables. What we're doing here is we're assigning that what we're going to call t-test of extroversion is our language of t-test from this data set of this variable used as means and this variable used as the different groups. And this is an assumption that we're setting. So now you understand what this command means, right? We're assigning this t-test to whatever name that we designate here. And then we can ask for the results of what we designated. So t-test extroversion is assigned to this. T-test agreeableness is assigned to this, so on and so forth, right? So it's very important to understand all the commands because without understanding it, you won't be able to apply it in other contexts, right? So let's copy and paste the commands and run it. So now we have names of what we designated, which assign t-tests to all the names, and it will give us 8 results because we asked to print 8 t-tests, right? So if we look at each, the group 1 in our data set, let me look at the group. In our data set, group 1 was male, group 2 was female. So it looks like extroversion were higher for females, but the difference was very minimal, that the p-value was not smaller than 0.05. So there were not a significant difference between male and female in terms of extroversion. Let's look at agreeableness. Agreeableness had a pretty high, pretty significant, a low p-value, much smaller than 0.05. We can see the decimal point is much smaller than 0.05 here. So the difference was that the female group had a higher agreeableness, and this group difference did not contain a zero, which means that it is statistically significant. The difference is non-zero, therefore it is significant. So female had a significantly higher agreeableness than male. Let's look at preseason hope. P-value was non-significant. The group difference contained a zero. So with a 95% confidence interval, it suggests that it could be a zero when we apply it to the larger population. So there was no group difference in terms of preseason hope. What about state hope? There was no statistical significance. What about student involvement? Oh, it had a statistical significance at an alpha level of 0.05. So we have kind we have 5% risk of type 1 error. We're confident at 95% that in the population level, there is a group difference in terms of student involvement. It looks like female were more involved with the school than male. And if the standard deviation for the groups were very large, um, then this little difference would have been non-significant. But based on our analysis, the errors and standard deviation looks small enough so that there is a significant difference here. What about team ID? This had an even smaller p-value, so we're more confident. We have a stronger effect size of confidence that there is a group difference. And when we look at the mean, it looks like this time male had a higher team identification with the football team than the females. When we look at attendance, there were no gender difference in attendance. And when we look at flourishness, well-being, there were no difference across groups. So it looks like agreeableness and team ID and student involvement were the variables that showed group differences in terms of gender, right? So now let's start working on ANOVA with these eight variables with degrees. So we had 6 degree measures ranging from freshmen, so sophomore, junior, senior, master's, and PhD students. So what we're going to do first is we're going to command we're going to command that degrees ordered is a factor that we can use to run as a factor. So we run this before we run an ANOVA so that R knows that this is a factor where we can use it to compare the mean differences for the each data point in the factor. So after we designated degree ordered as a factor variable, then we can run these commands. First, we will designate the variables of interest are these 8 variables, right? So we're assigning these variables to the dependent variables that we are interested in. And we're going to create an empty list of ANOVA results. And this list will be filled in with our ANOVA command. So if I would read this command to you, the variables, we're going to analyze the 8 variables that we designated dependent variables, right? And the formula to run the ANOVA is we're using degree ordered as the difference groups. And this is the ANOVA command in R. We're designating that the ANOVA results is a function of running the ANOVA command in R with our formula is that degree ordered is the factor and our data is from here. So our that will run from our data set this ANOVA test where degree ordered is the factor. That is the factor where we have 6 different mean groups, and we're uh, across those 6 groups, we're analyzing if there's a mean difference in those 8 variables. So there will be 6 means of extraversion for each group ranging from freshman to PhD, 6 mean score for agreeableness for each group, so on and so forth. And we're analyzing if there's any mean differences there. And then we're asking to print a summary of the ANOVA results that we assigned R to do, R to run, right? Analyze. So I'm going to drag all these commands to run the ANOVA and run it. This will give us 8 ANOVA results. So when I look at the ANOVA result, um, and before I read the interpret the results, this is why I designated that I want uh, this to be, um, uh, I mean, the variable name of the ANOVA result to be reported before each report, each ANOVA table, because if you don't run this, let me show you. Oh, I'll have to do everything again. But let me show you. Yeah. So if I would run this ANOVA without this command, then it will just show me the 8 ANOVA results, right? So I don't know which ANOVA result uh, of I don't know which table is showing which variable. So it's very inconvenient. So that's why I included this command to show the variable name before each table. So if I run it with this command, it shows me that uh, which variable it ran for each table. It's showing which variables mean different test is for each table, right? So if we look at extroversion, there was a significance among the groups. For agreeableness, we did not have a significant mean difference within the 6 degree levels. Preseason hope had a pretty high significance, showing the p-value had a lot of decimal points. And state hope, we did not have a significant difference among the groups. There was some significant difference in terms of student involvement and team ID and attendance, right? For flourish well-being, we did not have a significant difference as the p-value was larger than 0.05. Great. So we found some significant difference by degree levels. But I told you that ANOVA only detects if there is a significant difference. It doesn't tell you where the difference is. So we're going to run a post hoc test, which is uh, s- there's lots of different types of post hoc tests, but we'll just use the two keys HSD test, which is kind of a very generally used post hoc test. So for me to read this command to you, we're assigning what is a two key results, and two key HSD is the R's command, and we're running the two keys HSD for our ANOVA results designated here, right? And I'm asking for report of showing the title of which variable of the report is, and then I'm going to ask to print the two key results for the variables. All right, so let me run this command and it will give me 8 2 keys post hoc results. So if we look at the first one, which is for extroversion, it had only one significant difference where the p-value was smaller than 0.05, was that compared to freshmen, it looked like seniors had a significant level of extroversion compared to freshmen. So, mm, this is interesting. So maybe they learn social skills to show extrovert kind of um, characteristics, or maybe this is just based on our samples characteristics. So that's kind of interesting. For agreeableness, there were no significant results, so we'll pass on that. Let's look at state hope. Here we see that PhD students had a significantly lower preseason hope than freshmen. Well, maybe PhD students have less hope for the team in general. I don't know. But this is interesting finding to me. Another thing I found was the PhD student had a much significantly lower preseason hope, even for compared to sophomore. And comparing seniors to juniors, seniors had a little hope than juniors, and PhD had much smaller hope than juniors. So PhD showed significantly less preseason hope than any other group. And in terms of group differences, it looks like, yeah, it looks like juniors had the highest level of preseason hope. So this could create lots of different types of interpretations, right? Maybe the juniors have more insight to why the team would be better, or they endured enough that they think their team deserves a better result because the information about the roster would be same, and in like common sense, from what I would think that maybe freshmen would have higher preseason hope because they're excited for the football season, or maybe they were too disappointed during their freshman year. I don't know, but there could be lots of interpretations here based on their preseason hope. State hope, in terms of state hope, we didn't find any significant differences. In terms of student involvement, juniors had a significantly higher involvement than freshmen. So it looks like juniors are, from our sample, juniors are very highly involved, and I think they have a lot of interest to the football team's performance as well because they're invested in school activities. Let's look at Team ID. So this is very interesting when I look at Team ID. Well, PhD students had a much lower Team ID, so maybe that's why they don't have a high preseason hope. And again, PhD students compared to sophomores, they had a much smaller Team ID. Yeah, so PhD students had all difference. Only the insignificant was with the masters. All other significance. Uh, so PhD students in general had a much lower team ID than any other students. So that's very interesting. In terms of difference among masters and undergrad, I don't see much differences there. So it just shows that PhD students have much lower team ID. Very interesting. Okay. In terms of attendance, masters and PhD students had a significantly lower attendance intention compared to undergrad students. In terms of within the undergrad students, seniors had much lower attendance intentions than freshmen. So I understand that freshmen might have the highest on the attendance intention because they're new to the university and they have to experience it, right? People have variety-seeking behaviors and curiosity of trying to know what it is. So that makes sense to me. And all other differences is usually with um, graduate students, but there were also differences. Um, in general, the lower level um, students had higher attendance intentions. So that's very interesting. All right. In terms of flourishing, which is well-being, there were no significant results. So we will just skip this part. But after you look deeply inside to which groups had a different mean, I mean, significantly different mean, you get to develop insights and find the right interpretation. If you tested this statistical difference based on a theory, you might have a better reason to interpret these results. Maybe if we would hypothesize that I mean the lower level students would be more willing to seek for new variety. Maybe based on that, we could interpret that our statistical tests reflect that and supports that hypothesis because the lower level students in general had a higher attendance intention. And you can kind of um, now, when we wrap up this session, you should be now confident that you know how to compare mean difference with two groups as you did with using gender. And now you know how to run ANOVA. And uh, once we detect difference in ANOVA, we use the post hoc test to identify where the difference is located. And based on that, now you can kind of apply this knowledge to with to run different kind of mean difference or create categories within our data set or even other data sets that you might have a chance to run. So you could code ethnicities as you want because we have lots of Caucasian in our sample, and all other groups are relatively low in numbers. So we might just group all the other groups to others and compare two groups. If we create that, we could run a t-test for ethnicity, Caucasian versus others. Age is not a categorical variable. It is a continuous variable, right? So it doesn't need to be ran as a t-test or a ANOVA. Running a correlation makes better sense. However, if your interest is comparing group differences across generations, for example, Gen Z, Gen Y, etc., then you might want to classify the age into generational categories and run group difference tests. So there's some ways to apply this skill into lots of different ways in terms of how you would code your data. And you can run two keys um, two keys tests for only to show the only significant results. And you can ask ChatGPT to create a prompt you got to first let the ChatGPT know the commands that you use to run your ANOVA and two keys test. And you could ask ChatGPT to modify the prompt just to show the significant results. Yeah, so you could do that, and you could also create a APA formatted ANOVA table by using this command. Let me do this for you. So we're going to load the APA tables library. we did install the package early on in the previous week. So we don't need to install the package because it's already installed. We just need to load it into our library. So I run it, and after I run it, I'll refresh our files window by clicking the home button. And now you see that ANOVA tables are generated for each variable. So we had a significant difference in team ID, right? So let's see how that Word file looks like. It's gonna look like this. So this is the APA style report of an ANOVA test. So this is some cool feature. And let me show you how you might want to do this additional activity. So let me go to Gemini. I'm going to start a new chat. And I'm going to show the ANOVA command that I ran. Yeah, starting from here. Below, sorry, below is the ANOVA command that I ran in R. Can you modify the two keys test command to show only post hoc tests for significant differences? And I'll paste the command that I used. And let's see what AI gives us. So AI created this two keys test performance. So let me copy and paste this to see if it works. So let's see what we have here. All right. So this is what AI gave me. So I'll try to run it. And it's only showing the significant differences, right? So for extroversion, the only difference we found was difference between seniors and freshmen. We did not have any difference in terms of agreeableness. All PhDs had differences, and seniors had lower preseason hope than juniors. Nothing for state hope. One difference, juniors had higher student involvement than freshmen. For team ID, yeah, PhD students had much lower team ID. In terms of attendance intention is where we found the most difference. In general, higher level students had lower attendance intention. So that's what we found, and that's very interesting. So freshmen had the highest attendance intention level. Um, Seniors had 0.65 lower point mean than freshmen. Seniors compared to sophomores, the difference was smaller than compared to freshmen, and so on and so forth. You can find very interesting results. All right, so this is how you run t-test and ANOVA and find insights based on the results. So for your progress report, copy and paste all the information in your console and interpret which t-test and ANOVA models were significant. Mention those in your document and submit it for this week's progress report. All right, I hope this video was helpful for you, and I will meet you in our next module.